Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. You've probably seen the T-table before, rows, columns, lots of numbers. But finally in this video we'll get to see what all of these numbers mean, why do we have one tail and two tail columns, so that the table doesn't feel just like a chore to memorize, but it actually makes sense to you and you can use it whenever you need to do hypothesis testing. So what the T-table actually gives you, the most important thing to understand is that the T-table doesn't give you exactly probabilities in the same way we talked about the normal distribution table, but it gives you critical values, meaning you've got numbers on the horizontal axis such that observations beyond them are considered in extreme. So let me just write this because it's very important, and we're going to use this sort of definition in another video when we go over the concept of the p-value. So the T-table gives you critical values, meaning numbers on the horizontal axis such that observations beyond them are considered extreme. Okay, so basically the table that we're going to see is answering how far from zero is too far. Remember when we looked at the normal distribution tables, I told you it's very important to look at the legend that the table is giving you. This table is from the Marduk and Barnes table, the same book that I showed you even for the normal distribution table. Look very carefully in here. We still have this area that is being highlighted, that it's on the right-hand side, so literally the tail. When we did the normal distribution, we computed it as the probability 1 minus whatever the area on the left was. In here, keep in mind, this is the legend that we're given for this particular table. There will be tables where you don't have such a legend. For instance, the Wooldridge book gives you the critical values of the t-distribution, so using the same wording that I just gave you now, so it gives critical values. As you can see, the sort of information is very similar for the both. You've got the degrees of freedom that go on this column in here, and then you've got the infinity, which is where the t-distribution was collapsing into the z-distribution. In the previous graph, I didn't have space to paste the rest of this table, so it doesn't show, but there is an infinity line in here as well. You can use whichever table you want. Today, since the Wooldridge book, it's a little bit more accessible to anyone who's studying econometrics, I'm going to be using this table for anything going forward. So as you can see, we've got the column with the degrees of freedom. Just a reminder, we said degrees of freedom measure how much uncertainty remains after estimating the variance. So it means that on the fewer bit in here, this is where we have heavier tails. This is where we have larger critical values. So heavier tails and also larger critical values. As we keep going in this direction, so we're increasing the sample size in here, we've got more degrees of freedom, which means that the tails are becoming thinner as we go in this direction. And as you can also see, then the numbers themselves are going to become smaller. So smaller critical values. Okay. Now, of course, for the numbers that are provided in here, the values becoming smaller might not be exactly evident because they move from 1.3 to 1.2, but nevertheless, they are becoming smaller. The other element that you see in the t-table, which was not in the z-table that we saw for the standard normal distribution, is that now you've got a one-tailed and a two-tailed row. So one tail versus two tail. Why do we really need to have information for both of those? If I asked you a question, are we looking for extremes in one direction or in both directions? And depending on your situation, sometimes your answer will be one direction and sometimes it will be in both directions. That means that, well, the critical values for both cases surely should be different. This is why we need the one-tailed or the two-tailed test. So the tails, we're looking at the direction of the extremes. So if we have the t-distribution looking like this, are we looking at extremes on this side where we have the negative numbers? Are we looking at extremes that are on this side, or are we interested in looking at the extremes regardless of the positive or the negative side? When we have a one-tailed test, or the one-tailed critical values, we are looking at extremes in one direction. Okay, so for instance, we're going to use these numbers to answer questions. Is the effect positive and large, or is the effect negative and small? So you only care about one tail, one direction. For the two-tailed one, you are just interested, am I far enough from zero or not, regardless of the direction? So is the extreme far from zero in either direction? So what you care in here is either very positive values or very negative values, and you are looking in both tails. So the number of tails comes from the question that you ask, not from the data. So be very mindful of that. Now, because the t-distribution is symmetric, keep in mind that a two-tailed test splits the probability across two tails, and a one-tailed test puts it all in one tail. So keep in mind, the reason why you have in here, for instance, for a one-tailed, a 10%, while for this one, a 20%, is exactly because of this relation and because of the fact that the t-distribution is symmetric. Which means that if you have a one-tailed 10%, that would have been equivalent to a two-tailed 20%. Or if you had a 2% on a two-tailed, that would have been equivalent to a 1% in one tail. So that's why the t-table basically has separate columns. Keep in mind, it's not arbitrary numbers, it's just geometry and using the symmetry of the t-distribution. Okay. Now, let's look at a concrete example. For instance, let's assume we have 10 degrees of freedom. So I'm highlighting the line where I have the 10 degrees of freedom. If I can see in here for the two-tailed test at the 5%, meaning I am looking at the two-tailed, I need the 5% right here. So moving down, my critical value is this number in here, 2.228. Okay, so how do I interpret that number? Before that, let me show it to you in a graph. So let's assume this is the t-distribution. We've got 0 in here. So what I'm saying with the two-tailed at the 5%, it means that I'm looking in both directions, okay? And that means that if I'm looking at 5% in both directions, I'm also looking at 2.5 in each. So it means that I've got the 2.5% in this part and then 2.5% on this side. Now, the number that's inside in here, remember it's a t-score, so it's what goes into this horizontal axis. And according to that, for the degrees of freedom 10, this is just where the 2.228 is situated. And because this is symmetric, this is where the minus 2.228 is situated. So interpretation, any t-statistic larger than 2.228 in absolute value is considered too extreme. And I'm going to add something else in red in here, which is going to make more sense once we look into hypothesis testing, but I need to add it here for the sake of completeness. Under the null. Okay, so don't emphasize too much on that under the null. It'll make more sense later. Now let's look at the 5% on a one tail though. Okay, so that means now I'm looking into the one tail and I'm looking at the 5%. So it means I'm actually looking in this column. And if I go down in here, it means the critical value that I have right now is actually 1.812. So what I'm actually doing in the one tail one is that I want the entire 5% to be right here. So it makes sense that actually the number, the critical value that I have will be different. So in this case, this is where the 1.812 is actually situated. And keep in mind, the interpretation, it's exactly the same. So smaller cutoff because all the probability now is in one tail, and it just means that any t-statistic larger than 1.812 in absolute value is considered to be too extreme under the null hypothesis. Now that you've seen an actual example, let's make a summary of how to use the table step by step. So the first step should always be decide whether you are working with a one-tailed or a two-tailed test. So usually this is given context to you from the exercise that you're solving. You don't just arbitrarily choose it. If you're not given whether it's a one-tailed or two-tailed, in that case, you can arbitrarily choose it yourself right at the beginning. The second one is choosing your significance level, which is what I have done in here by saying, in this case, for instance, 5% or 2.5% or 10% and so on. Step 3, find the correct degrees of freedom. In this case, I arbitrarily picked degrees of freedom 10. Keep in mind that will be dictated from your information in your exercise. Step 4 is read the critical value. And ultimately, step 5 is to compare the t-statistic to the cutoff. Now, this final step, again, might not be too clear what it's doing right now because it's usually the last step that you have in hypothesis testing. And after that, there is a decision rule. But for now, these are the steps that you usually need to follow. Common mistakes that students make is they choose the tails after seeing the result. That is wrong. Keep in mind, this was your step one. You decide whether it's a one-tailed or a two-tailed, depending on the context that you're given on the exam right off the bat. Mixing one-tail logic with two-tailed columns, always be very careful with that. Once you decided it's a one-tailed or two-tailed, keep focus and keep the correct column that you should be looking into. The other common mistake is that students think of the table, that the table gives you p-values, and sometimes they also ignore degrees of freedom. You have to be very careful. As a rule of thumb, I always tell students that you need to draw a nice picture to have an idea of where you're looking for your extreme values. So, as a rule of thumb, if you don't draw the picture first, you'll very likely choose the wrong column as well. So make sure that you always have a visual for what you're finding, which is going to make also your life easier whenever you look at this t-table and find your actual extreme value. So the t-table told us how extreme is too extreme, given the degrees of freedom and your question. In the next video, we'll step back and answer a deeper question. What is a p-value really, since we talked so much about extremes in here? But p-value is one of the concepts that is very crucial in econometrics. So stay tuned, and I will see you in the next video.